Hello C# programmers! My name is Tony, and in today's video I will teach you what variables and data types are in C#. I will give you some examples, and together we will create our first functional application that uses input from the user. If you want to know how, then stay tuned and watch till the end. In general, variables in programming are containers where you can store values that you will need to use later in your program. For example, if you want to store information about yourself, you should create a variable for your name, your age, your height, your pet's name, etc. etc. These variables are stored in the RAM memory of a computer and can be accessed or modified relatively fast and easy. Each variable has fixed size determined by its data type, and usually this size is measured in bytes or sometimes in bits. Let's jump straight into Visual Studio and create our first variables. If you don't have Visual Studio installed on your machine, I would suggest you to watch my previous video where I guide you step by step through the process. I will give you the link in the description. Here we are, and this is the code we were provided with after creating a basic console app. I will stick to my previous example and will define two variables for the name and the age of a person. Let's delete this line because it's not useful at the moment and write our first lines of code in C#. We need two main things to create a variable: its type and a descriptive name that will be used to identify it among all other variables. Now let's imagine that our main character is called Brian and he is, for example, 19 years old. We can write var name equals Brian, and on the next line var age equals 19. In C#, like in some other programming languages, every statement should be finished with a semicolon, so do not forget it. We can access the value contained within a variable using its name. And now I will give you a quick example. Let's write these values to the console using the method console.writeLine. We simply need to pass the value that we want to see later written to the console. In our case, this is the name and the age of our main character. Do you remember how we can execute our programs within Visual Studio? If your answer is the key combination Ctrl F5, then you are right. Let's execute our program to see if the correct values will appear. And actually, we've got what we have expected. Congratulations! As we have created these two variables, let's modify their values. Our new character should be called Anna, and she is 27 years old. As I said before, we can access the value of a variable through its name. We can modify it the same way. We simply need to write the name of the variable, which value should be changed, equals, and the new value. Let's do exactly the same thing for her age. And now, after we execute the code, we can see that there no longer is written Brian, who is 19 years old, but instead Anna, who is 27 years old. The primitive types can be separated in four groups: integral numeric data types, floating point numeric data types, Boolean data types, and data types for storing characters or text. Let's focus on the first one, integral numeric data types. They differ from each other by their size and their range of possible values. For all of them, their default value is 0, and there is one peculiarity that the literals of type uint and ulong should have the suffix u at the end. It doesn't matter if it is lower or upper, and the literals from type long should have the suffix l. The integral numeric data types can be easily memorized in couples. For example, int goes with uint, and the only difference is that with int we can store negative numbers, and with uint we cannot do it because its range of possible values starts from 0. Actually, uint is shortened from unsigned int, and it is unsigned because we should not necessarily put that plus sign in front of the literals of that certain type. The same logic can be applied for long and ulong, for short and ushort, and for byte and sbyte. You should also notice that the range of possible values for these types increases accordingly to the size they take up from a computer's memory. For example, byte and sbyte take up only 1 byte from our memory, but we cannot store very big numbers, as you can see. At the same time, we should compare it with long and ulong that take up 8 times more memory from our computer, but we can store numbers up to 19 digits long. Now let's go through the floating point numeric data types. There are only 3, and the main difference is their precision and their size. These two parameters are related to each other, so the more size a data type takes up, the more precision it should provide you. You should remember that precision includes the digits before the floating point. For example, if we want to store a number that has 9 digits before its floating point and 2 after it in a variable of type float, it is most likely that that number would simply be trimmed after the 9th digit, and we will lose the information after it. Each floating point data type literal should have a suffix. For float, that suffix is f, for double, that suffix is d, and for decimal, that suffix is m, because most usually that type is used for storing an amount of money. If such a suffix is omitted from the literal, it is implicitly converted to double. The Boolean data type in C# is called bool, and like in most other programming languages, it has only 2 possible values, true or false. And that's why it takes up only 1 bit, that in our memory should be represented as 1 or 0. In C# there are 2 data types where we can store characters. The first one is the data type called char. There we can store only 1 character, and it should be obligatorily enclosed in single quotes. You can see that if I change them to double quotes, that leads to a compiler error. Also, if I remove that character or write more than 1 characters, that is also a compiler error. That type takes up 2 bytes because it is a Unicode character. The next data type is string. There we can store a sequence of characters. We should obligatorily enclose that sequence in double quotes. I will give you again an example where I change from double to single quotes, and you can see that this is a compiler error. It takes up n multiplied by 2 bytes from our memory, where n actually is the number of characters stored in that particular string. You should notice that until now we haven't actually talked about the var keyword. Var is not a data type, but a keyword that gives the programmers the opportunity not to write the type of the variable whenever it is implicitly inferred during its initialization. I will give you a quick example. Var a equals abc. Now, it's apparent that ABC is a string literal. So the type of our new variable will also be string. In general, we can also initialize a variable without its initial value to be specified. I mean, we can do int b semicolon and later in our code to initialize it. B equals, let's say, 14. But that is only a available solution if we specify explicitly its type. You can see that if I change this to var, a compiler error appears. At the beginning of this video, I promised you that together we will create our first functional application. So let's get started. We will create an application that reads from the console a name of a person and then simply prints out hello and the previously entered name. Let's create a variable where we can store the name of that person. We can read something from the console using the console.readLine method. Now, how can we print something to the console? If your answer is using the method console.writeLine, then you are correct. Let's write hello. Let's put a little space here and concatenate it with the previously entered name. Let's execute our program. As you can see, the console is waiting for our input. I will enter Tony, and that's it. Hello, Tony. If you liked this video, give it a thumbs up and subscribe for TryAtSoftware for more interesting content. See you next time, programmers. Wish you happy coding.